Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss NCERT questions for the wave chapter. So I have already done lots of question. Okay. So in previous part I have done till 14.7. So today I am going to discuss question number 14.8. So first of all, we should read the question so that it will be better. So here in 14.8, a transverse harmonic wave on a string is described by yxt as 3.0 into sine 36t plus 0.018x plus pi by 4, where x and y are in centimeter and t is in second. The positive direction of the x is from left to right. So x in this direction it is negative and in this direction it is positive. Is this wave traveling wave or stationary wave? If it is traveling wave, what is the speed and direction of its propagation? So let us understand what is the wave, what is the equation of the wave. As we know that the equation for a progressive wave is equation for progressive wave is a sine omega t plus kx plus phi when wave move from right to left, when wave move from or travel from right to left, right to left. It means that wave moving in this direction. Okay, so the movement of wave is in this direction, so we have got this equation. If we see the above equation, so we can compare the above given equation is y into x into t. So we have 3.0 into sine 36t plus it is 36t plus 0.018 x plus pi by 4. From above, if we compare, by comparing what we are getting, by comparing, we get amplitude A is equal to 3 centimeter and K is equal to 0.018 and phi, that is phi is equal to pi by 4. Okay. Now from the above, we can say that the given equations are wave is traveling. Okay. So here wave is traveling, right? Wave is traveling. Now they are asking the speed of the wave. So we know that speed of the wave is equal to, one more thing they have given omega. This is omega, this is omega. Omega is equal to 36. Now we know that speed of the wave, speed is equal to omega by k. So omega is 36 and the value of k is 0.018. So when we calculate this, so this way we will get as 20 meter per second. So I hope this is the required result for A. Okay. Now let us go for the next question. Next part is, what is the amplitude and a frequency? So we have already done, this is the amplitude. So the amplitude we have already done. Now the B part, that is amplitude. B part, it has amplitude. So amplitude will be equal to 3 centimeter. Okay. And what is the frequency of the wave? So frequency So if you want to find frequency, so what will be the formula? Let us write here the formula. Frequency that is nu is equal to omega by 2 pi. Omega by 2 pi. So the value of omega is 36 and value of 2 pi. So this will be 2 pi. So when we do this, we will get approximately 5.7 hertz. So this is the required frequency for B part. Okay. So I hope you have understood now. Now what is the initial phase at the origin? So the initial phase means what? Phi. So the phase, we have already compared this above equation. So phase means pi. So phi is equal to pi by 4. So our phase is pi is equal to pi by 4. So this is our required phase. Okay. Now what is the least distance between the two successive crest in the wave? So if it is a wave like this, see here, wave is like this. So the distance between two crests, it is a crest. So distance between two crests is known as lambda. So they are asking about the lambda. So how you will do lambda? So we know that lambda is equal to 2 pi by k. So we know the value 2 pi, but what is the value of k? So we have already derived k as wave number. So by comparing, we have got wave number as 0.018. So finally, when we calculate it, so we will get lambda is equal to 349 centimeter. So this is the required result for this question. I hope you have understood this. Okay. Now, so we have already done all the parts of this question. Now let us go for next question. Okay. In next question, it is 4.10. It is 4.10 for the traveling harmonic wave yx in t 2.0 cos 2 pi 10t. These are the equation, and x and y are in centimeter and t is in second. Calculate the phase difference between oscillatory motion of the 2 points separated by the distance of 4 oscillatory motion of a 2 point separated by the distance of 4 meter, distance of 0.5 meter, and lambda by 2 and 3 lambda by 4. See, first of all, we have to write the equation properly. Okay. So let us write the equation properly. Y is a function of x comma t. What we can write here? So y is a function of x comma t. We can write here 2.0. So this is 2 cos 2 pi. If you multiply inside, so cos 2 pi multiplied by 10t. So this will be 20 pi into t minus 0.016 x plus 0. So this will be pi, because there will be a multiplication of the pi. So this is 0.016 pi x plus 0.7 pi. So this is the exact equation. Okay. Now we know the equation that this is our amplitude. So the value of amplitude A is equal to 2 centimeter. Value of omega is 20 pi. Value of k is equal to 0.016 pi. and the value of phase is how much? So phi is 0.7 pi. Okay, now we know that the best formula for this. Phi is equal to kx, and this is equal to 2 pi by lambda. So this is very important formula. Okay, now calculate the phase difference between the oscillatory motion if the 2 points are separated by a distance of x. Okay, so how you will find this? See, think about this, how you will solve this. Just put this value. See, we have already wave number k. So for case 1, that is A, in A, x is given as 4 meter. Okay, x is given as a 4 meter. So you can convert it into centimeters. So this will be as 400 centimeter, right? So the phase difference phi is equal to k into x. So this will be k. K is equal to 0.016 into x. The value of x is 400, and this is not only 0.016, so this pi will be multiplied. So this will be 6400, but there is 6.4, so 6.4 pi. So this will be 6.4 pi. The final phase difference for this is 6.4 pi. Okay, now let us do for a B part. If we talk about part B, so part B, they have given x as equal to 0.5 meter. So this will be 50 centimeter. Okay, so now the phase difference will be equal to kx. So this will be equal to 0.016 pi into 50. So this will be equal to 16 5 18 800. So 800. So this will be 0.8 pi is the phase difference. Okay, and all the things will come in a radian. So put here radian. Okay, now for x is equal to, see, x is equal to lambda by 2. If you put x is equal to lambda by 2, so what we are going to get? See, phi can be written as k into x. Okay, k into x. See here, one thing you should understand here. It is not see, phi is equal to kx and k is equal to 2 pi by lambda. Okay, so this is the relation. K is equal to 2 pi by lambda. This relation is there. Okay, now since here see phi is equal to kx, so what we can do here? I is equal to kx, what we can do here? In place of k, can we put here 2 pi by lambda? And in x, we can put here lambda by 2. So lambda got cancelled. So this will be pi will be equal to 2 got cancelled. So pi will be equal to pi. So the phase difference is pi. Now let us do same for question number D. It is saying that the value of x is equal to 3 lambda by 4. So now the phase difference is equal to kx. So k is equal to 2 pi by lambda. 2 pi by lambda into x has a value 3 lambda by 4. So lambda got cancelled out. 2 ja 4. So this will be ja 4. So this will be equal to 3 pi by 2. So our answer for this question should be our answer for this question should be 3 lambda by 4. So 3 lambda by 4. So answer for this question will be 3 pi by 2 3 pi by 2 radian. Okay. So this is our required answer. I hope you have understood this. Now go for the next question. Next question. Next question. The the transverse displacement of the string. The transverse displacement of the string clamped at its both ends is given as this, where x and y are m and t in second. The length of the string is 1.5 meter and its mass is this. Does the function represent the traveling wave or stationary wave? See, one thing you need to understand that here the equation y is equal to x comma t is equal to 0.06 into sine 2 pi by 3 x is given into cos 120 pi into t. Here value of k is equal to 2 pi by 3 is given, and value of omega as we are getting from here, it is 120 pi. So k and omega both are kept separately, one in a sine and one in cos. So this represent stationary wave equation. So whenever you will find that these are separate, then you can say directly that is uh, it is a stationary wave. Okay. And when it is combined form, for example, a sine omega t plus kx plus phi, like this, then it means that it is your traveling wave. Okay. Got it? Now you have understood now. Okay. Now let us go for next question. Interpret the wave as a superposition of two waves traveling in opposite direction. So we know that two waves traveling in opposite direction. So one wave is in moving in right direction. So wave in a right direction. So this will be a sine omega t minus kx. Wave traveling in right direction. In right direction. Now y2 is a sine omega t plus kx. It is wave traveling in left direction. Okay. Now superimposition of two wave. When we superimpose, then what will happen? Y will be equal to y1 plus y2. So this will be basically a sine omega t minus kx plus a sine omega t plus kx. Now we have to add this. So we have to break this. So it is a sine omega t cos kx minus a sine kx cos omega t plus, again we have to break like this, a sine omega t cos kx plus a sine kx cos omega t. So this will get cut. So finally it will be 2a sine omega t cos kx. Okay, 2a sine omega t cos kx. Got it? Uh, See here, one thing you have noticed that these are similar to the equation y is equal to 2a sine 2 pi by lambda into x into cos 2 pi frequency into t. Okay, so finally from the above equation we can interpret that the any stationary wave is the superposition of the two wave, which is one is going in right direction and another is going in a left direction. Okay, now here we need to find frequency speed of the each wave. Okay, wavelength. So wavelength from here, wavelength, what is the wavelength? So wavelength is equal to 0.06 meter. Now frequency, before that we need to understand what is the value of k. So value of k, or we can say 2 pi by lambda, this is equal to 2 pi by 3. Okay, so not it is the amplitude, so it is better to find like this. See here, 2 got cancel out, so from here lambda will be equal to 3 meter. So this is the wavelength of the wavelength, right? Now we can find frequencies. Okay, so frequency, so from here 2 pi nu 2 pi nu, that is frequency, is equal to 120 pi. So pi got cancel out, so this will be frequency will be 60 hertz. Okay, now let us calculate for velocity of the wave. So the c part, velocity is equal to lambda into frequency. So lambda is 3 into frequency is 60, so this will be 180 meter per second. I hope you have got this result. Okay, determine the tension in the string. So now it is very challenging that how to find a tension in the string. Okay, we have already got all the values, so let us put here the values. We have mass, we have 6 into 10 to the power minus 2 kg. Length of the string, length is how much? 3 meter. and mu, that is mass by length, is how much? 6 into 10 to the power minus 2 divided by 3. So this will be 2 into 10 to the power minus 2 meter kg per meter, kg per meter. So this is the mass density. Now we need to find tension. Okay, so the tension will be equal to what? This will be equal to v square into mu. So v square means 180 into 180. Why 180 into 180? Just now we have find out the velocity of the wave. So the velocity of the wave 180 into 180 into mu is equal to 2 into 10 to the power minus 2. So when we calculate it, so we will get the tension as 648 Newton. Okay. So this is our required result for this question. I hope you have understood 4.11. Okay. Now let us do this question. Before that, we have to read this question. For the wave on a string described in exercise, it is not for 14, it is 14.11. Do all the points string oscillate with the same frequency, phase, amplitude? Explain your answer. See, see here, as we in a question, it is written that it is clamped at its both the end. Okay, as wire is clamped at both the ends, it will behave at ends, will behave as node. Behave as node. See here, let us make it fix. So what will happen? If you vibrate it, if you plug it, so this both end will behave as a node. Okay, and the whole wire vibrate in one segment, and the whole wire vibrate at one segment, right? Now see, they are telling that do all the points on a string oscillate with the same frequency? Yes, definitely. But it won't at the if you will talk about the node point, except node except at node, all point will vibrate with same frequency, right? Since all the particle of a wire lie on a one segment only, since all particle lie on one segment, so they have same phase. They have same phase. Got it? Now let us talk about the C point. C. They are talking about amplitude. Amplitude See, you need to understand, if I am talking about the wave has been created like this. At this point, there will be different amplitude. At this point, there will be different. At this point, there will be different amplitude. When it reverse also, so what will happen? The particle at this point will have an amplitude of about this point only. Anti-node point has a maximum, and this point has a minimum. See, node point has a minimum. So we can say that amplitude will be different for different for different point. Okay. Now, what is the amplitude of a point 0.375 meter? So we have a equation. See, we have equation as, now we have equation as y, that is amplitude equation, is equal to 0.06 into sine 2 pi by 3 into x into cos 2 pi into t. Now for x is equal to 0.375 meter, and when we consume that time is equal to 0, so what will be the amplitude? So the what at a 0 time, the amplitude will be 0.06 sine 2 pi by 3 into 0.375 meter into cos 0. Why? Because it will be become 0, so cos 0, it will be cos 0, so cos 0 will be 1. So finally, if you find the amplitude, so the amplitude will be approximately equal to 0.044 meter. So this is our required result, right? So I hope you have done with this. Now let us go for question number 13. In question number 13, given below are some of the functions of x and t to represent the displacement, transverse and longitudinal of an elastic wave. State which of these represent traveling wave and stationary wave. So I have already told you that what does traveling and what does SHM wave has an equation. See, if omega t and kx are separated, it means that they are traveling wave. Sorry, they are in combined wave. So let us do here. Y is equal to 2 cos 3x into sine 10t. Here k and omega, kx and omega t are separate entity, right? Separated. So this is your stationary wave, okay? Now we can go for B. So in B, y is equal to 2 root under x minus vt. See, this equation does not contain any of the harmonic term. Harmonic term. So it is neither none at all. None at all. Okay. Now let us go for C. In C, we can see that 5x minus 0.5t, 5x 0.5t. Actually, sine and cos both are, see, x and t. Kx and omega t are appearing as combined form. So it is traveling wave. Now let us talk about D. D, if we talk about D, so this is a cos X, cos A, sin B, cos 2x 2t. So this is different entity. See here. See, we can say that this both are are kept separately, this are kept separately. So it is the combination of two different stationary wave. Okay, it is combination of two different stationary wave. Okay, so I hope you have understood this. Now let us do the question number 14.4. Before that, we need to read. A wire is straight between two rigid support, vibrates in its fundamental mode. So fundamental modes are there with a frequency of 45 hertz. The mass of the wire is 3.5 into 10 power minus 2 kg and its linear mass density is given like this. So what is the speed of the transverse wave on a string and the tension in the string? So first of all, we must note down what they have given, right? They have given frequency that is equal to 45 hertz. They have given mass as 3.5 into 10 to the power minus 2 kg, and the linear mass density, that is mu, is equal to 4.0 into 10 to the power minus 2. So from here can we find the length? From here we can find length. So length will be equal to what? See, mu is equal to mass by length. So from here length will be equal to mass by mu. So mass is how much? Mass is 3.5 into 10 to the power minus 2 divided by mu is 4.0 into 10 to the power minus 2. Got it? So finally we need to divide it. So when we divide it, so we will get the value which is length, this is equal to 0.78 meter. So we have got the value of length. Okay. Now our target is that speed of the transverse wave, right? So before that we need to find the lambda. So lambda, we will find lambda? So we know that lambda is equal to 2L by n, where n is which mode? Fundamental mode. N is equal to 1 means it is fundamental mode, or fundamental mode is there. Okay, fundamental mode. Okay. Now n is equal to 1 for a fundamental mode is there. So what will happen? So from here we can get lambda as lambda is equal to 2 into L. So from here we can get 2 into 0.78. So if it will be multiplied with the 2, so we will get 1.56 meters. So we have got lambda. Now the speed of transverse wave, this is equal to lambda into frequency. So the value of lambda is 1.56 into frequency is 45 hertz. Okay. So if we multiply this, so we will get speed of a transverse wave as 70 meter per second. Now the tension in the string. So tension in the string T is equal to mu into V square. So we have mu is how much? Mu is equal to 4 into 10 to the power minus 2 into V square. So V square means basically what? V square means velocity square. So velocity, how you will get velocity? Not V square. Basically, it is a time period, right? It is a not V square. We can say it as a mm, velocity is equal to root under T by mu. So from here we can get, yeah, tension is equal to V into V square. Okay. So mu is given, velocity we have got 70 meters. So 70 into 70. So this will be into 70. We have got 4900 into 4 and it should be divided by 100. So this will be approximately 196 Newton. So I hope you have got the answer for this question. Okay. Now let us do next question. Next question. There is question, a meter long tube open at one end with movable piston at the other end. See here, there is a long tube. Sorry. There is a movable piston, so it will be up and down. So one side it is fixed, and other side it is opened. So basically, it will act as a pipe. It will act as a pipe with one end closed and one end open. So the mode or the frequency or the mode, it will make like this. Okay. So there is one node and there is a 20 nodes. So it is incomplete now. Now what we have to do, we know that if we know the length, this is a length. So this length has same value, that is equal to lambda by 4. Okay. Now what they have given, the frequency is equal to 340 hertz, right? And the length of the pipe, we will consider length of the pipe as 25.5 centimeter. So this will be 0.255 meter. Okay. So we have got length. From length we can find out lambda. So lambda by 4 is equal to length. So from which lambda is equal to 4 into length. So this will be 4 into 0.255. So when we multiply it, 4 into 4 into 4 into 0.255. So this will be 1.02, approximately 1.02. So we have got the value of lambda as 1.0 meter. Now what we want to find, see, estimate the speed of the sound in air. Okay, speed of the sound in air. Okay, so we know that speed, that is equal to lambda into frequency. So lambda is 1.02 into frequency is 340. So from this we can get the answer as 340, right? So we will get 346.8 meter per second. So this is the velocity. Okay, it is not the frequency. Frequency is different thing. See, this is frequency and this is velocity, right? Okay, so I hope you have understood now. Now next question is 14.16. In a 14.16, A steel rod of 100 centimeter long is clamped at its middle. The fundamental frequency of the longitudinal vibration of the rod are this. What is the speed of the sound in a steel? See, there is a steel bar. There is an steel bar, okay? There is an steel bar, and we will clamp it here at the middle point. So what will happen? It will try to vibrate when we give the jerk or anything. So it will try to vibrate. So the vibration will create a node and anti-node like this. This will create a node like this and anti-node like this. Okay. So from here, this is node, this is anti-node, and this is anti-node. From here, we know that this is our lambda by 4. This is also lambda by 4, right? And the total length they have given as 100 centimeter means 1 meter, right? Length of the steel rod they have given. So from here, length is equal to lambda by 4 plus lambda by 4. This will be equal to lambda by 2. So lambda is equal to 2 into length. So this will be 2 meter only. Okay. So lambda we have got as a 2 meter. Got it? Now they have given that its frequency, fundamental frequency is 2.53 kilohertz. So if their fundamental frequency is 2.53 kilohertz, so from here what we can derive? So we can find the velocity. So velocity will be equal to lambda into frequency. So lambda is how much? Lambda is 2 into frequency is 2.53 kilohertz. So when we multiply it, so we will definitely get, it is kilohertz. So sorry, it should be converted into hertz only, 2.53 into 10 to the power cube hertz. So this will be 10 to the power cube hertz. So 5.06 into 10 to the power 3 meter per second. Okay. So I hope you have understood this. Okay. So for this next part video, I will